All right, welcome back, guys. So in this video here, we're gonna talked about basic differentiation rules or properties. In the previous video, we introduced the definition of derivative, and that was a long definition. The notation is f prime of x, and to find the derivative of a given function, we take the limit of this difference quotient by letting h go to 0, and then whatever that is going to be the answer, and that answer is going to be the derivative of the function of x, and then also the slope of tangent line as well at that point on the graph. In this lesson, we're going to introduce the basic rule. It's called the power rule, which is going to bypass this long method here. We don't have to do this in this section. But before we get there, let's introduce the notation first. So there's three different notations that you need to know for derivative. So notation of derivatives. Okay. So if we're given a function y equal to f of x, then these following notation all represent derivative. So we can either look at that as say, okay, well, f prime of x will be the notation for the derivative, or y prime, since y equal f of x, or you can do the change of y over change in x, so dy of dx. This means take the derivative of y with respect to x. All three mean same things. Okay, so all represent the derivative of f at x. Okay. The first rule we're going to introduce is called the constant rule. Okay, so the first rule, so it's called the constant rule, constant function rule. Okay, all right. So this is saying that if a function is equal to some constant c, where c is a number or constant, then the derivative f prime of x is equal to 0. Okay, so let's see why this rule is the way it is. If we're given a function and let's say f of x equal to 3, for example, well, this function here is just a horizontal line passed through the y-axis at 3, right? Well, if this is a horizontal line, in algebra we know that horizontal line has a slope equal to 0. All right, it's a flat line has a slope equal to 0. So derivative f prime of x equals 0 for all x, meaning at any point on this line here, whether here, the steepness or the slope at that position on the line is going to be 0. So the derivative of any constant is going to be 0. Okay, so that's going to be the first rule. This is probably the easiest one to remember. Okay, the next rule is called the power rule, and let me just go ahead and move this down here. The next rule is called the power rule. This is saying that, so this is called the power rule. Okay. So the power rule for derivative is saying that if f of x is equal to some y, or y equal to f of x. Let me just rewrite that. So we have a function. Let's call that f of x, and this is just a function of y here. This function here is in the form of x to the n, where n is a real number. Okay, so if we have a function in this type of format, this is a polynomial format, some power n where x just input, then to find the derivative f prime of x is just by bring down the power n times x and then subtract the power by 1. Okay, so instead of us going through this long method here, to find the derivative by taking the limit of that different quotient, to find the derivative function, we can just use the power rule. Okay, so this would be the formula that we're using to find the derivative of any polynomial in this form here. Okay, so those are the two rules that we're gonna use in this section to do a lot example until we become familiar with the rules. So let's start with some example here. Okay, so let's start with some example. Find the derivative for the following functions. Okay, so let's start with A. If a y is equal to, let's say, x to the 7, okay, so if we were to do the long way to find the derivative, we would have to do this difference quotient, and then when you evaluate f of x plus h by plugging x plus h into x to the 7, and we're looking at something like this here, to the 7 times. There's no way we want to spend that out 7 times and simplify that. Okay, we're not doing that. So that's why we have this shortcut rule introduced for that reason. So let's go ahead and do it. Let's see. Using the power rule, we can bring down the power 7 and then subtract the power by 1. So that gives us 7x to the 6. So the function 7x to the 6 is the derivative function of this x to the 7. Okay, let's do an example. Okay, let's go ahead and introduce a constant in front of, actually, you know, let's just do, yeah, we're not, let's do 3x to the negative 4. Okay, so notice that this x to negative 4 is still fit this format here, so we are going to use the power rule. Well, what about the constant in front? So it turns out there is a rule that a constant times a function, we can just take the derivative by taking the derivative of the variable and then times the constant afterwards. So you don't have to write this, but I'm gonna write it for you just one time to see, you know, what the properties is saying here. They're saying that the derivative is actually equal to just 3 times the derivative of this polynomial here, right? So we just leave the constant in front and times that that result here, the derivative of this x to negative 4. So using the power rule, the negative 4 comes down, and then x, and then take that power, subtract 1. So that will give us negative 12 x to negative 5 as our final answer for the derivative. Okay, so I'm just writing this step here to show you guys that you can do it. You can times the constant after we take the derivative of the variable part. Okay, let's go and do another example. Okay, so what if we have f of x equal, let's do x to the 3rd over 6. Okay, well, in this case here, the constant in front of the x is not 6, but it's 1/6. So we want to rewrite this as 1/6x to the 3rd, and then apply the power rule. So 1/6 times 3, powers comes down, and then take the power minus 1. So that gives us 1/2 x to the 2nd power. All right, so that would be our derivative function there. All right, so let's move on to example 2, and I've already typed this out. Let me add a page here. A page. Okay. All right. Let's move this up. Okay. All right, so let's do these 4 parts here. So A, f of x is 1 over x to the 4th. In order for us to use the power rule, it has to be in this form of x to the n power. So we want to write this so that way it has x in the numerator. Well, to bring x to the 4 to the numerator, the power becomes negative, right? So now we can just apply the power rule. So that's negative 4x, negative 4 minus 1. So that's negative 4x to negative 5. So that is our answer. B, y equal to radical of u. Okay, so same thing. In order for us to use the power rule, we have to make sure that it's in this form x to the n or u to the n. Well, we have a radical. So what we want to do here is we want to rewrite that radical as a power. So to square root a number is the same thing as take that number raised to the 1/2 powers. So now we can take the derivative using the power rule. We bring down the powers, and then we take the power minus 1, and that becomes 1/2 u to negative 1/2. Now you can actually write this as 1/2 square of u if you want to prefer that as positive exponent. So either way is fine. C, we have d dx of x to the 5/3. So this saying that find the derivative of x to the 5/3. So that notation is still asking us to find the derivative, d dx. Differentiate this x variable. So we're going to say, okay, let's bring down the power. And then take the power minus 1. All right, so that gives us 5/3. And then 5/3 minus 1 is 2/3, because 1 is 3/3. So that's our answer. Okay. D, y equals t to the negative 2. All right, so to do this here, we just apply the power rule again, bring down the powers, take the power minus 1. So that becomes negative 2t to the negative 3. Again, if you want to change this to positive exponent, that's just put the t to the third in the denominator, and then the power becomes positive. Okay. All right, I'm going to pause at this point here on this video. In the next video, we're going to go over this example I've already written down here. This is one of my favorite example. So I think I'm going to save that for the next video.